All right, this video is going to be on matrix multiplication. So first we have to go over how to tell if matrix multiplication is possible, and if it is possible, what would the dimensions of the product be? So if you have a matrix A times a matrix B, and the dimensions are m by n, and B's dimensions are n by p, the dimensions in the middle must be equal. And then the dimensions of the outside gives us the dimensions of the product. So remember, when I say dimensions of m by n, that means I'm talking about rows by columns. So here, if we call this matrix A and matrix B, then matrix A here is 3 rows by 3 columns, and matrix B is 3 rows by 2 columns. And since the middle dimensions are equal, so they're both 3 there, then it is possible. And the product A times B will have the dimensions of the outsides, which is 3 by 2. So the product of AB will have the dimensions 3 by 2. So that's what that means, how to tell and what the products of the dimensions of the product will equal. So is the product possible? If so, what are the dimensions? Let's practice that first. So in A, this is a 2 by 1, and then this is a 2 by 2. These are not equal, so this one is not possible. In B, we have 1 by 2 matrix and then a 2 by 2 matrix. Since the middle dimensions are equal, it is possible, and the product, the dimensions would be a 1 by 2. So it would make a 1 by 2. So the outside dimensions give us the product. Okay. And C, if we take A times B, so A times B would be a 2 by 5 and then a 5 by 1. So yes, that is possible. And our answer would be a 2 by 1. If we took B times A, we'd have a 5 by 1 times a 2 by 5. These are not the same, so this one is not possible. No. So that's something to note. You can multiply A times B, but you can't multiply B times A. And here, if we did A times B, we'd have 4 by 1 and a 4 by 1. So no, you can't do that. If you did B times A, you'd have 4 by 1 times 4 by 1. So again, no, the middle dimensions would never be the same there. This one in D is not possible either way. Okay, so we're going to explore this idea in C a little bit more here in example 3. So I have my matrix A and my matrix B, and we're going to find the product. So this is how we find the products. So you take rows by columns. First, this is going to be a 2 by 2 matrix times a 2 by 2 matrix. So our answer, our product will be a 2 by 2 matrix. We will have 2 rows and 2 columns, column 1 and column 2. We're going to take, how you multiply matrices is you take rows times columns. So you take the first row times the first column, and it works like this. You take the 2 times the 3, so 2 times the 3, plus, then you do the negative 3 times the 2. Since that was the first row and first column, it goes in the first row, first column spot right there. Then you take the first row times the second column, and you take the first one times the first entry and the second one times the second. So you take the 2 times the negative 2 plus the negative 3 times the 0. And since that was the first row and the second column, it goes in the first row, second column spot. Now we're done with the first row. So then we go to the second row. Now you take the second row times the first column. So that's going to be 4 times 3 plus 1 times 2. So you take the two products and then you add them together. Then you take the second row and the second column. And that'll be 4 times negative 2 and 1 times plus 1 times 0. And since that's the second row and the second column, it goes in the second row and second column spot right there. And then we do the addition. So here we're going to have 6. Whoops. Sorry, I got my zoom on there. Just shut that out. Shut that off. So I have 2 times 3 is 6. And then I'll have plus negative 6 there. I'll have negative 4 plus 0. I'll have 12 plus 2. And negative 8 plus 0. And then simplify that one more time. Final answer is going to be 0, negative 4, 14, negative 8. So that is my answer for A times B. So let's try it one more time, but this time we're going to do B times A. Again, we have a 2 by 2 and a 2 by 2. So our answer will be a 2 by 2 matrix. We'll have 2 rows. And we'll have column 1 and column 2 as well. Now, this just helps me kind of organize my thinking. So I take row 1 times column 1, and I put that in row 1, column 1 spot, which is right here. And you're going to multiply the 3 times the 2 plus, and then negative 2 times the 4. I'm going to need a little bit more space, I think, here. And then I'm going to do row 1, column 2. So 3 times the negative 3 plus negative 2 times 1. So I'm done with row 1. I've multiplied row 1 by each column. So we're done with row 1. Now we move to row 2. And you do row 2 times column 1. And that goes in row 2, column 1 spot right here. So that'll be 2 times the 2 plus 0 times 4. And then row 2 times column 2. In row 2, column 2 spot, so 2 times negative 3 plus 0 times 1. And then I can do the multiplication here. And you're going to get 6 plus negative 8 there, negative 9 plus negative 2, 4 plus 0, and I get negative 6 plus 0. So reducing that, I'm going to get 6 plus negative 8 is negative 2, negative 9 plus negative 2 is negative 11, 4 plus 0 is 4, negative 6 plus 0 is negative 6. So this is my answer for B times A. So what do we notice about A and B? What I notice is that I got 2 separate answers. So A times B is not equal to B times A. So matrix multiplication is not commutative. Commutative property is the property that says like 3 times 4 is the same thing as 4 times 3. And multiplication is typically commutative, like 3 times 4 is 12 and 4 times 3 is 12. But matrix multiplication is not commutative. So you get different answers and if you multiply the matrices in a different order. So that's very important to remember. All right, let's keep going here. Let's try this one. So find the product if it exists. So this matrix here, the first one is a 3 by 3 matrix, and the one to the right is a 3 by 2 matrix. Since my middle dimensions are equal, I can find the product, and my answer will be a 3 by 2 matrix. And so, so I would have then row 1, row 2, row 3, because it's going to be a 3 by 2, and then I'm going to have column 1 and column 2 in my answer. Then you have to keep yourself very organized, but what you're going to do is you're going to do row 1 times column 1, and that's going to go row 1, column 1 spot. So row 1, column 1 right there. And then you have 3 numbers. So you're going to multiply the first ones, then multiply the second ones, then multiply the third ones. So it's going to be 4 times 10 plus 0 times 0 plus negative 9 times 6. And then you have to take row 1 times column 2 now. So row 1 times column 2 will go up top in column 2 section. So that'll be 4 times 1 plus 0 times 3 plus negative 9 times negative 2. Okay, we're done with row 1. We've done row 1 with each column. Now, if there was a third column there, we'd have to do it one more time. So you do each row with each column. When you're done with the row, then you move on to the next row. So now I want row 2. So now I'm going to be in row 2 spot here. And then column 1 will go right here, row 2, column 1 spot. So I do 1 times the 10 plus the 3 times the 0 plus the 8 times the 6. And then I'll do row 2 times column 2. It'll go in column 2 spot. So I'll have 1 times the 1 plus 3 times 3 plus 8 times negative 2. So I have now done row 2 with both columns, so I can start with row 3. Since we're in row 3 now, I'm going to put that in row 3, column 1 spot. So row 3, column 1 will be the negative 1 times 10 plus 5 times 0 plus negative 11 times 6. Then row 3 times column 2 be negative 1 times 1 plus 5 times 3 plus negative 11 times negative 2. All right, now go back through and do the multiplication. I always save this for last. So 40, 0, negative 54, 4, 0, 18, 10, 0, 48, 1, 9, negative 16, negative 10, 0, 66, negative 66. Negative 1, 15 here, and 22. And then adding those up are going to give me my final answers. So 40 plus negative 54 will be negative 14. 4 plus 18 will be 22. Row 2, column 1, 10 plus 48 is 58. Row 2, column 2, 10 plus negative 16 will be negative 6. Row 3, column 1, I'm going to get negative 76. We got 15 plus 22 is 37, minus 1 is 36. So there's my final answer for that one. Just checking my work quick with what I got earlier. All right, so not so bad, but it does take some serious organization skills here. Now, there is a way for you to do this with the graphing calculator, and I plan to show that to you in class. Or you can Google how to do matrix multiplication in a TI-84 and find a video if you'd like to watch that. But on your test, you'll still need to show me that you can do matrix multiplication by hand. So I'm going to ask you a question like this, where it says, find the element in the second row and third column of the product AB. So that means I want you to show me the math for the second row and there is no third column. So we probably have to change a second row and we'll do first column. So second row and then first column would be like, show me the math for those two being multiplied together, which would be 0 times the 1 plus the 1 times negative 3 plus negative 1 times 0. So I end up with just negative 3. So that would be how you show me the work. So you're just showing me a long way of how you would get the answer. If I want let's say, first row, first column of the product, I want the first row with the first column. So that would be 4 times 1 plus negative 2 times negative 3 plus 3 times 0. So that'd be 4 plus 6, which would be 10. So you're showing me just the long work for one complete step of the row, and then you would use your calculator to find the rest to just save you some time. Okay, so matrix multiplication can be used a lot of times if you think of anything that can be put into spreadsheet data. So, think back to when you're putting in numbers into a table in science, or you're putting in numbers at work into an Excel chart. If you can put the numbers into a table, you can do matrix multiplication with it. So here's an example. 2 lacrosse teams submit equipment lists for their sponsors. Women's team gets 5 sticks, 15 balls, and 16 uniforms. Men's team gets 8 sticks, 12 balls, and 17 uniforms. Each stick costs $55, each ball is $6, and each uniform is $35. Use matrix multiplication to help find the total cost of the equipment for each team. So we're going to set up a matrix like this. Whoops. Sorry. We are going to have women here and men's team here. And we're going to do sticks, balls, and then uniforms. So the women's goes 5, 15, and 16. And the men's goes 8, 22, and 17. And then I want to make another matrix. So this one's a 2 by 3 matrix. So I'm going to have a 3 by something. And I want it to correspond to the cost. So since I go sticks, balls, uniforms, I'm going to go sticks, balls, uniforms down the side. So the sticks cost $55. Each ball is $6. Each uniform is $35. And now I can multiply. When I multiply, you'll see that I'm going to take the women's. So if I do these, this is 2 by 3 times 3 by 1. So I'm going to get a product that's 2 by 1. And I'm going to take the women's the women's equipment times the cost. So that's going to be 5 times 55 plus 15 times 6 plus 16 times 35. So you can see that it took each of the women's pieces times the cost of that piece. And then for the men's, it would be this times the row. So 8 times 55 plus 6 times 22, or 22 times 6, plus 17 times 35. And then finishing off the math here, so 5 times 55 plus 15 times 6 plus 16 times 35, I'm going to get 925. And then for the men's equipment, 8 times 55 plus 6 times 22 plus 17 times 35, I'm going to get 1,167. And so it's $925 for the women's equipment, and it's 1,167 for the men's equipment. And that's just an example of a way you can organize the data in kind of like a spreadsheet and then use matrix multiplication to find a total cost of something. Okay, that's all I have for you on matrix multiplication. Thanks for watching.